Hello everyone, myself Nishant Bide. Today me and my teammate are going to explain you about force acting on current carrying conductor placed in magnetic field and rule to understand the direction of force. So let's get started. It all started in 1820 when Ørsted discovered that a conductor carrying a current is always surrounded by a magnetic field along the length of conductor, which means a current carrying conductor produces a magnetic field around it, that is, behaves like a magnet and exerts a force when a magnet is placed in its magnetic field. Similarly, the magnetic field also exerts equal and opposite force on the current carrying conductor. This is because when two magnetic fields, that is, the magnetic field produced by the current carrying conductor and the magnetic field due to nearby magnet, interact with each other, there can be an attraction or repulsion between them. This attraction and repulsion are based on the direction of the external magnetic field and the direction of the current in the conductor. If the direction of the magnetic field and the electric current is perpendicular to each other, then the force acting on the conductor is perpendicular to both current and magnetic field. This concept is also important for understanding the basic principle of operation of DC motor. In this figure, we can see a straight conductor is placed in a magnetic field produced by a permanent magnet. Let us consider that the current flowing through the conductor is coming out of the plane of the paper, that is towards the observer. As the current is coming out of the field produced by the conductor, it is shown in anticlockwise direction, and the magnetic lines of permanent magnet move from north pole to south pole. Due to the presence of two magnetic fields simultaneously, there will be interaction between them. Either it will be of attraction or repulsion. The flux lines produced by the magnet and the conductor are opposite in direction to each other. Hence, the number of flux lines at the top will reduce. At the bottom, the individual fields are in same direction. Hence, they will strengthen each other. Therefore, number of flux lines at bottom will increase. Hence, the lines of force at the bottom will exert a force on the conductor in upward direction. Hence, mechanical force gets exerted on the conductor from high flux line area towards low flux line area. Thus, if current carrying conductor is placed in magnetic field, then it experiences a force as a result of an interaction between their individual magnetic fields. The rule to understand the direction of force will be further explained by my teammate.
So now let us understand the rule which is used to determine the direction of the force experienced by a current carrying conductor placed in magnetic field. So it is given by Fleming's left hand rule. Now let us understand that what does Fleming's left hand rule states. It states that when the first three fingers of the left hand are held mutually perpendicular to each other, then the thumb indicates the direction of the force, the first finger indicates the direction of the magnetic field, and the middle finger indicates the direction of the current. Now we will understand the magnitude of the force experienced by a current carrying conductor placed in magnetic field. It is given by F is equals to BIL and its unit is Newton, where B it is the original flux density, I is the current flowing through the conductor, and L is the length of the conductor. Now we have understood that whenever a current carrying conductor is placed in a magnetic field, it experiences a force, and the direction of the force acting on a current carrying conductor, it is given by Fleming's left hand rule. Thank you.